What's quantum computing?
You know what quantum computing is?
No, but I have no idea what that is.
Oh, you're gonna have to come with me, man. You need to learn about this.
Dude, I'm busy. I have a class in a few minutes.
Trust me, this is way more important than class. If quantum computing is made effective, it can change the world.
Well, what is quantum computing?
Well, quantum computing is a form of computing that uses quantum physics. It's different from the classical physics that we use in classical computing. Do you know what a bit is?
Yeah, of course. Who doesn't know what a bit is? A 1 or a 0 that a computer processes?
Right, that's exactly what a bit is. A classical computing system uses a bit, a 1 and a 0, and that's where it ends and that's where it stops. Nothing more, nothing less. Now, it processes millions of these in seconds, but it still takes time to switch from a 1 to a 0 and vice versa.
Okay.
Here, let me show you something. With quantum physics, there's this principle called superposition.
Well, what is superposition?
It is when a particle, such as an electron or a photon, exists in two states at the same time.
Wait, what?
Quantum computing uses the power of superposition by using qubits. Alright? See, a classical bit can either be a 1 or a 0. That's it. One or the other. A qubit can be a 0 or a 1 at the exact same time.
What? 1 and 0 at the same time?
Yes, the same time.
Like, it doesn't even make sense.
No, it doesn't have to make sense, but quantum physics is real. You see, some particles exist in multiple states at once. Take Schrödinger's cat, for example.
Whose cat?
Physicist Erwin Schrödinger. In 1935, he developed an interesting experiment and example to explain superposition. He developed an experiment where he took a box, he added a cat to the box and some radioactive decay. This is all theoretical. Now, the idea of the experiment is we don't know if the cat was killed by the radioactive decay or not. So they're both alive and dead at the same time until we open the box and observe it. In the same way that the cat is both alive and dead until we observe it, the qubit is also 1 and 0 until we observe it.
Wow.
By using this technique and others such as quantum entanglement and quantum tunneling, we can accomplish tasks with a quantum computer that would take a normal computer thousands of years to accomplish.
Really?
Yes, but there are some issues. Ever since 1900, when Max Planck founded quantum theory, scientists have been baffled by what they were finding in the subatomic universe. Even Albert Einstein was flabbergasted. Scientists are still discovering ways of how to harness the full potential of quantum mechanics to build quantum computers. It's not an easy task, even up to 1986 when physicist David Deutsch first laid down the principles of quantum computing. We didn't have the technology to actually build a quantum computer. In 1998, the first quantum computer was built, consisting of a mere 2 qubits. Thanks to D-Wave, the only quantum computer business in the industry, we've come a bit further. I guess you can say that's a bit of a monopoly.
Ha!
D-Waves is creating computers with over 1,000 qubits in it. That's impressive. That's able to analyze the amount of observable particles in our universe simultaneously.
Dude, I think my head is gonna explode.
Don't get too excited. D-Wave still has not completed a true quantum computer. D-Wave's computers can only solve optimization problems, which is good because classical computers can't do it nearly as well, but they still can't solve all of the same problems that a classical computer could. So we're still in the infancy stage of quantum computing.
I think I'm gonna cry, man.
Don't cry. Scientists are getting closer to true quantum computing every day. Once scientists master the art of quantum computing, the possibilities are endless. Weather forecasts will be amazingly accurate, with quantum computing able to analyze all patterns and possibilities simultaneously. New medicines and cures will be found using quantum power to analyze all the molecular structures at once to find the ones that are the most likely to work. Using quantum computing, our military will be able to create an indestructible barrier to protect our nation by analyzing enormous quantities of data to find any potential threats. Space exploration will be dramatically improved using quantum computing, allowing telescopes to gather more data than currently possible about planets and stars outside our solar system. With a quantum computer, everything encrypted on the internet today will be able to be decrypted almost instantly, so quantum computers will have to make new encryption methods. In the meantime, the possessors of a fully functional quantum computer will be able to find every password, read every private message, and access practically all previously classified information.
Man, that's messed up.
It does present somewhat of a moral dilemma, but the positive does outweigh the negative aspect of it. Everything has a positive and negative side, right?
Of course.
The big picture is that quantum computing is going to change the world. Some scientists estimate this could be in the next 20 years. Computers today are going to look like ancient artifacts compared to a quantum computer in the future.
Yeah, that's cool, but I think you have problems. Yeah.
At least Schrodinger's cat never leave me.